2.1. 2.1 is going to be starting off by talking about the standard form of a quadratic function. The first thing we need to understand is that the vertex form a x minus h squared plus k, where a cannot be 0. So the vertex is that hk. Now we've talked about the hk with the circle, and it still has the same kind of meaning. It's an important piece to our picture. It is a turning point or a change point. Notice that when we talk about a vertex, the h is an opposite because it's inside the parenthesis, just like it was in a circle. It's an opposite sign. But the k is not in a parenthesis. The k is out separate, and it is the same sign. So that's the first thing we really need to be aware of when we're asked for what is the vertex and what is the hk of that. H is always going to be opposite sign, whereas k is going to be the same sign. And basically, if it's in a parenthesis, it's always going to be opposite. If it's outside of a parenthesis, it's always going to be the same. So when we start moving our parabolas, instead of being up and down, and we start making them go left and right, and we start making some changes to the locations of h's and k's, the rule of thumb is if it's inside a parenthesis, it's an opposite sign. If it's outside alone by itself, then it's going to be the same sign. So when we look here at these first 4 examples, just pause the video for a second and see if you can pick out what is the vertex, what is the hk of each parabola. So pause the video, work out all 4, then come back and I'll go through them. Number 1, hk is going to be 3, 7. 3 is the opposite sign, 7 is the same. Vertex on number 2 is -5, -9. Number 3, 1, -11. And on number 4, -9, 2. All right, now we're going to be able to actually write the equation of a parabola with the vertex given an hk and it going through an xy. So if I know my vertex, then I know my hk, and if I know a point, I know my xy. So when I look back up here at this standard form of quadratic function, my y equals, because f of x means y, a, that's some coefficient of my my parabola, and so far, everything we talked about with our a is based on if it's positive, it opens up. If it's negative, it opens down. Well, now if we're going to write an equation, we actually need to find that a, because we know x, we know h, and we know k. What we don't know is the a. So the very first thing you have to do when you're asked to find an equation is you have to find a. So we're going to use our general form up here, the standard form, and we're going to plug everything in except a so that we can find it. So y equals a, x is 3, minus h squared plus k. Now we do our arithmetic and we go and simplify this so that we get -6 is 3 minus 1 for 2 squared is 4. Move over the 2. So our a is -2. So what is the equation? Well, the equation then is f of x, because we do want to write it in function notation, a x minus h squared plus k. So fill in the actual h and k. All right, on number 6, find the equation of a parabola. Again, same thing. We're just going to practice it again. So if you would, pause the video, take a couple minutes, see if you can come up with the a and the equation based on the hk and the xy that's given to you. So go ahead and pause and then come back and I will work through the problem. All right, we're going to find a by going y equals a x minus h squared plus k. Do some arithmetic here. We get 4 squared, or 2 and then squared is 4. We're going to move the 3. So a is negative 1/4. So what is the equation? It's f of x equals a x minus h squared plus k, is what you should have got when you worked it out. Alright, on this next set, we're going to write the following in standard form, showing the work by completing the square. Now I'm going to show you a little bit different technique to completing the square than what we did in the last chapter. The last chapter we completed the square when we were solving for our x-intercepts. Well, we're going to use completing the square so that we can change a standard general form of a quadratic into the vertex form. And that's one thing I want to point out up here. We also call this vertex form. So be aware that for our purposes they will be interchanged there. So we want to change this ax plus by plus c into this vertex form. So the way we're going to do that is complete the square. So here's the steps in order to do that. We're going to take out the leading coefficient of the first 2 terms. So in this case, we're going to take the 3 out. When I say take it out, we're factoring it out, GCF it out. So here we're going to get left over x squared minus 2x. All right. I'm going to leave a space and then the parentheses. So ignore that parenthesis I just wrote there. Leave a space. And then I want you to put a minus and then another space plus the 12. And that 12 comes from what we did, what was on the back side of this equation. So we have 2 spaces. We have one inside the parenthesis and we have one outside the parenthesis. So what we need to do is we need to fill in those 2 spaces. Again, ignore that parenthesis there that I have there. That's a mistake. And I don't have any white out. Alright, so we're going to still follow the complete the square process, which is we take our middle term, we divide it by 2, we square it, and then we're going to add that inside the parenthesis. That's what we're going to add. But the outside space, we're going to subtract. Now, we're not going to be subtracting 1 because this 1, even though it's inside, has a 3 on the outside. So we have to multiply it by 3, and that's what's going to go into that space. Because when I added 3 here, and that's technically what it is because if I were to distribute, then to keep the equation even, I would have to subtract 3. And that's always going to be the case. Whatever we take out here, we're going to have to multiply to what we put in order to fill this second space. Alright, so continuing with our completing the square, we're going to leave our 3. The reason we complete the square is because we know this makes a perfect square, and it's always whatever we got when we divided by 2. And now I get to combine minus 3 plus 2 for a positive 9. So f of x equals 3, x minus 1 squared plus 9. That is the work for completing the square. Now you are going to have to do more with this. After you find this equation and complete the square, you're going to be asked to find 3 or 4 things really. The vertex, the x-intercept, the y-intercept, and then you're going to be asked to graph it. So we might as well go through those processes. You might need another piece of paper or use the back side of this worksheet is fine. But we want to start with what is the vertex, because that's the easiest thing to pick out. The vertex is opposite and same sign. Now the x-intercept, we have to do a little bit of work, so I'm going to hold off on that one. And then I'm going to do the y-intercept, because that one's easy. The y-intercept, we can go back up to our original and put zeros into x's. So therefore, the only thing left standing is the constant 12. So that's our y-intercept. Our x-intercept, we have several ways. We could factor the original. We could put 0 in for y and solve it, which is the best kind of option. And then we might have to use quadratic formula. We might have to use some other options in order to actually solve for it. So for the x-intercept, we're going to make the 0 y, or the y 0. And then I'm going to subtract the 9. Divide by the 3. Now when I go to square root this, when I square root both sides, I get that there are no x-intercepts because they're imaginaries. Because when I square root a negative, I can't get a real number. When I square root negatives, I get imaginaries. So I would say the x-intercepts are none. They're imaginary. So then what you're going to do is graph it. That's going to be the last part. So when I graph this, again, it doesn't have to be exact. Just know that 12 is probably up there, 9 is up there, here's 1. So 1, 9 is my vertex. There is my y-intercept. And when I connect the dots, I know it goes upward because my a is positive, but I also know it's not going to cross the x-axis because my intercepts are imaginary, meaning they don't exist. So you're going to be doing these extra pieces. You're not just finding the equation by completing the square. You're also going to tell me what is the vertex, what is the y-intercept, and what is the x-intercept with a graph. So let's go to this next example. Matter of fact, why don't you go ahead and pause it and try it and see if you can do it on your own, and then come back and I'm going to start working through the problem. All right, so number 8. First thing we're going to do is we're going to pull out the leading coefficient 5 so that we have a single x squared, and that works out nicely for the 2x. Going to leave a space that we're going to add in, and I'm going to leave a space that we're going to subtract, and then I'm going to put the minus 155. Okay. So now I need to fill in these two spaces. The way that I'm going to do that is I'm going to take the middle term, divide by 2, always 2, square it, and that's what I'm going to add inside. But on the outside, I've got to multiply it to the a, the number that was pulled out, the coefficient that I GCF'd out there. So I get 5. Now I'm going to get a perfect square. So x plus 1 squared minus 160 equals f of x. Put it in proper notation, equation notation. Alright, so we should be able to pick out the vertex without too many problems. The vertex is negative 1, negative 160. The y-intercept, again, we can go back to our original 0, 0, so it's negative 155. If not, you can put in 0 to the x location here and then solve it for the y, but it's usually easier to go right up here, 0, 0. The constant is the y-intercept. Then we have x-intercept, and the x-intercept means we're going to make the y 0, and we're going to solve for it. So I'm going to move over the 160. Then I'm going to divide by the 5 so that I get 32. square root both sides means I get two answers. Plus minus the square root of 32 is x plus 1. Okay. So when I subtract the 1 over, I get minus 1 plus the square root of 32 is x. I need to do some simplification here. 32 is actually going to simplify to 4 root 2. And this is fine for our algebraic work. The x-intercept is negative 1 plus or minus 4 root 2. The problem will come when I have to graph it. All right, so here we're going to put our graph together. Again, it's just a sketch. My vertex is negative 1 and negative 160. At negative 155, it's going to cross the y-axis. And then it's going to cross the x-axis at those locations. I don't know what those are off the top of my head, and I doubt you do either. So you do need to put that in your calculator and come up with approximations and find that it should be approximately 4.7 and negative 6.7. So we're going to say 4.7 and negative 6.7 so that when I connect my dots, it goes through all of those important points, the vertex, the y-intercept, and the x-intercept. Again, these are sketches. They're not exact, but they do show that you know how to put your pieces of information together. All right. Now this last one, go ahead if you want to pause, try it. The only problem is that when we do this, we're going to get a fraction. And fractions are okay, but we sometimes have a little problem with them. So when I pull out this 2, and that's what I have to pull out. I always got to pull out the a, because I need it to be an x squared. When I pull that out, I'm going to get 9 halves. Okay? Plus a space, minus a space, and then plus the 7. And actually, I'm just going to pull out another piece of paper. So once again, we're pulling out the 2, x squared, 9 halves, leaving a space, minus a space, plus that the constant that's on the end of it. All right, so we're going to take our 9 halves, we're going to divide it by 2, and that gives me 9/4. 9/4 squared is 81/16. 81/16 is what we're going to put into the first blank. But I have to multiply that by 2 because that's what the A is in order to subtract that on the outside. So that's 81/8. So now I have 2. This is a perfect square, so 9/4. We always get it when we divide by 2. Whatever we got when we divided by 2 is the number that goes there. Then I need to actually come up with 81/8 plus 7. If we get common denominators, combine all like terms, you should get that that comes to negative 25/8. Okay, so the vertex is the easy part to pull out. Negative 9/4 and negative 25/8. All right, the y-intercept is easy to pull out because in my original equation, 0, 0, my constant is 7. For the x-intercept, we're going to make the y 0. So we're going to move over the 25/8. We're going to divide by 2, and when I divide by 2, that's actually going to become the 16ths, so 25/16. Now when I square root both sides, I'm going to get plus minus 5/4 is equal to x plus 9/4. When I move over that negative 9/4, I get that my x-intercepts are going to be negative 9 plus 5 is negative 4/4. And then negative 9 minus 5, negative 14/4, for a total of negative 1 and negative 7/2. All right, so there's my equation, my vertex, my y-intercept, my x-intercepts. Now I need to put all of this together on a graph. On my graph, again, we don't need it to be exact here. Negative 9/4, so about negative 2 and some change, and negative 25/8 is negative 3 and some change. So we're going to be about there. The y-intercept is at 7. Okay. And we're going to cross at negative 1 and at negative 3.5. Connect the dots, and there's our parabola containing all of our information. So that is section 2.1.